Yeah, to talk about the future as from origin a greenhouse building company is quite exciting, though I think we're not the same innovators as Priva or Peter and not really in the same field, but we're with our boots in the dirt and working with the challenges of not only England but in the world. So I'd like to give a sort of overview of what we're doing and also maybe to inspire you what challenges we come across. First of all, I had to think for this presentation because the theme was energy storage, and I thought, why did we start to use energy? Because when we came on this planet, we didn't need much, we just needed a hut, and I studied architecture once, and the first, we called that archetype, was the Hawaiian hut, so it was the most basic principle to protect ourselves. So protection was the first stage until we discovered that we needed to travel to find food, and we needed to we find out how to burn things, to make fire. And I think the first energy storage was maybe the trees. So we burned a lot of them. Holland used to be Holtland, like the pre-German language. But there's not much trees anymore in Holland. So we used all of them. So I think that concept didn't really work well, but it was like survival. And the next one is cultivation. So the cultivation is we use the same trees to make timber boots and houses, and we find other sources to heat up the place, gas and coal. And the last one is then innovation, and I think that's the time we are at this moment in, because there's so many things going on, and we still use, in this example in Singapore, we still use the trees, but they have different function. It's attraction, it's solar energy harvesting, and it's also growing on the side, but still the tree. So I think the way how we use energy and how it symbolizes and the place it has in our daily society changed a lot. So this is an overview, no energy, wood, then the survival, we came to more sustainable, because we couldn't burn up everything. So I think we're in that transition, and the next step will be energy storage, smart energy grids, and I think we see that transaction also in horticulture already. So this is a small overview of horticulture, a bit like the same steps. It's an open field, then we just covered it, plastic greenhouses, then we got the glass greenhouses with more technology in there. We also got more knowledgeable how to grow. Then, well, we call that supprimaire, but it's the semi-closed greenhouse system, so where you start controlling more and more, actually what Priva is doing as well, so you start more controlling towards the plant. And the last stage is indoor farming, where you're not dependent anymore from the outside environment, but you're controlling everything, so you are the one determining the growing conditions. So what happens in this transition from the open field to the multi-layer? I think we are able to decrease a lot of our resources, so water is going down, labor is going down because of robotization, pest control is going down because we're in a more protected environment, but what goes up is the yields, that's the green one, so that's beneficial, and what goes up is the electrical usage, because we become more reliable on controlling everything ourselves, and we use electricity for that. But the system is not so simple that we only have energy and the crop. There's much more to it, which has impact on our system. So this is the ecosystem of food. I think it's all downloadable later on the page, so you can study it. There's a lot of systems having impact on it, and that's climate change, because we needed to protect ourselves and we need to heat up the place. We also need to cool at some other areas, so there's more water. Well, this is the rainy season, of course, so I think you recognize all of this. Soil quality, desalination of grounds, insect pests, water scarcity. So there's a lot of challenges, not all related here in the UK or in Holland, but worldwide, where a lot of people are living, it affects on daily base. Environmental change, also the population that grows, urbanization. This is an example of Dubai in just 25 years. From a desert area, we say, well, we can place the greenhouse anywhere we would like, to that there's actually no place anymore, not in the city. We have to deal with the desert in that sense. Technical progress, LED lighting, knowledge about control, knowledge about growing and plants. That gives more insight, and it gives also the need to more innovation. And the last is industry change, robotization, labor becoming more expensive, also less people that find it attractive to work in horticulture. So there's a lot of challenges going on, and all they have impact on how we design and what we have to do on a daily basis in greenhouses, and also how the look of greenhouses change. Then we have the other side of the ecosystem, that's the market, the consumers, people that are eating the products, more local produce because of political influence, year-round available because of stability of the food system, consumer awareness about that we trust the food, where does it come from, what happened with it, what story does retailers give the consumers, and do they still trust that? Price, quality, availability, and in the end, maybe in the future, this food part that's now for consummation gets a different meaning because of all this technology and innovation, that this becomes our medicines in the future. So in the end, food security covers, I think, the whole topic, because that's the result. That starts from the energy, the growing, the food production, the whole supply chain, and that we can get our food in the store. I think that's what we are working for on a daily basis, we as a technology supplier, and a lot of you as passionate growers. So our way is to find a solution in this whole game, and the greenhouse or the indoor farm is just a piece of it, and we have to deal with CHPs or with other solutions. But in the end, so they affect energy, food, and water. That's what we are most focused on in our innovation. So some examples which we come up, which are a bit different than the daily practice. So this is in Berlin, a local farming, so really to produce for the city, in the city, with aquaponic, they sell fish as well. Is this a winning model, and will this be the future of horticulture? I'm not saying that, because I don't think so, but it's interesting. It gives a move, and it gives us all something to think about what the consumer wants and how they experience food and production. A whole different solution is, because of political movement, Russian retailers that start producing their own vegetables. They don't buy it anymore in Europe because of the ban. They start producing it themselves. The drone couldn't fly high enough to get the greenhouse on. This is 20 hectares. CHPs, so energy implementation, going on for a long time, and if the energy market is suitable for that, then we see that occurring in different countries. Holland, it used to be for a long time. Now I think it's a topic for last years here in the UK. Energy that has influence. Also energy is in a different way with biogas. So what you actually see is that greenhouses start to be developed close to energy sources. In this case, a biogas installation in Germany. Here it's geothermal heat from a steam river in Kenya for rose production. In this way we do it a bit different, because not everybody has this geothermal. So we use solar heating to heat up the greenhouse only for the morning. So it's like an innovation on the heating part only. Orchard production, because they consume a lot of energy for the cooling and the heating. It's actually quite weird that we in Holland produce a lot of orchards. So we find out that we could store the heat and the cold in the ground in slow-moving layers with aquifers. I'm sure that topic is tackled in one of the conferences. Here in Poland, a greenhouse close to a coil energy facility, because the heat is for free. And using LED. So this is like an example of introducing more electricity in the greenhouse, the sun-tea lighting, and with the LED trying to do that more efficiently, gives a benefit in the growth and gives a benefit in the electrical usage. And the next step is combining more and more of these systems and actually making the system more smart and more connected to all these dots. And I think that slowly is happening. So in this case, we are is a project in France. It's with LED lights and controlling the climate in an artificial way with tubes for the ventilation. So you're more in control and become less dependent from the outside climate. I will tell a bit more about that system later on. This is an example of a tropical climate, subtropical, in Korea to produce bell peppers for the Japanese market, also with aquifers, and it's focused on a cooling system. Energy is quite cheap in Korea, so this system works there. So, and what we see is every country has its own challenges and opportunities. So there's a different solution for every market, for every crop, for every condition. And close then the last one for the UK, more automation in the greenhouses combined with LED lights to produce cleaner product. This goes to lettuce, goes to sandwiches. So no dirt, less pesticides, so less active components on the leaves. So it's actually a result of the retailer asking for a better and cleaner product. And this is the result of the greenhouse, not just because the grower wanted to do it like that one. And this is the same, different way, but actually the same question. This is more to deliver the retailer on time. That's why this grower started doing his own own propagation in a fully controlled environment. Only for that, and of course he could get a good subsidy by the time for the technology, but the reason was the retailer asking to be in time always. This year we will also make for a large vegetable processing company an indoor farm which produces lettuce only indoor and goes directly into the processing lines. So that's the next step, and this feasibility of these projects is under pressure because the investment of technology is quite high, but we will learn a lot of it, and the next step we can do that much smarter. So I'm happy with these entrepreneurs that they start finding new solutions, and also because they deliver salads to the German market because the shelf life needs to be increased. Less waste. The sourcing for the company is very complicated due to climate change in Spain and Italy, where a lot of rain and things happen. So they have to buy sometimes the lettuce from California to process lettuce in Holland for the German market. So you can imagine that's a weird world actually. And the retailers that demand less chemicals on the products to deliver a healthier product to the clients. So what we need in the end for all this innovation is more control on the growing of the crop, and we are slowly moving to a more closed system and using more technology and more energy for that. In our company we are working on producing vegetable crops without daylight, so with only LED light. That succeeds very well with tomatoes, bell peppers and cucumbers. That are the three that we now managed to do. And the yield results are really high. Simple because we are a bit better able to control the climate in uniformity, and we give more light over the year in a constant way. So the light sum is much higher than you would normally have. And the research of companies, seed companies, this is Rijkswaan, they are working on same technologies as well to prepare plants and production systems in the future, also for more closed environments where the plants don't have to be bred to resist drought or insect plagues, but can be actually produced to produce efficiently. And only for that sole purpose, because the climate is like a baby confused, it's perfect. So what we are looking for is less resources. I think we can manage, especially water. Very interesting for, here in Holland and here in UK we have a lot of water, but Middle East region and China and that kind of regions, that's a very important development for them. Well, the electricity usage we haven't solved yet. And then the sustainable, of the increase of production, that's the second one that's already from the plastic greenhouse to the indoor farm also increases. Up. So this is we managed at our facility to go to 160 kilos on a square meter, but with a high electrical consumption, of course. So with this all controlling of the climate, we're looking for the balance. I think the story of Peter was very well upstep to this one, because it's about balancing all the elements, the light, the CO2, and I think once we are doing that in a more measured way, then we don't have to spoil a lot of heat and electricity as well. So this is at the basics, old-fashioned basics, as I understood, but the picture was already in. So this is the scheme that we normally achieve, and the outside conditions don't give that hour automatically, so we need to do that in a different way. In a couple of steps, I want to go through the semi-closed system, because the principle is the same for an indoor farm or anything where you're more in control about controlling the climate and where you put your energy in for the growing. So in this system, you have components for ventilating air, for cooling it, for heating it, for reusing it, and for overpressuring the humidity to the outside. So that's all in one climate corridor. If this is an indoor farm, the concept is the same. The way how we integrate technology is a bit different. But this gives some insight about technology. It's fans and tubes that are below the gutters. There are more projects already, not only from our company, but there are many greenhouse companies making this concept. There's a big difference in a lot of projects, and that has to do with often with the dimension of the tube, which relates to the energy consumption of the fans. Because the smaller you make the tube, the less air you can ventilate through the greenhouse. And it depends on the climate where you are, how much ventilation is needed to get all the humidity and the heat from solar radiation out of the greenhouse. So in some schemes, so in a semi-closed greenhouse, you use the fans not anymore for ventilation, but it's an overpressure valve. So you overpressure the intake of air outside, and with that overpressuring that air to the outside, you remove the humidity from the inside. Here in UK for winter season, that would be very interesting. First of all, because you use very small quantities of air to dehumidify the greenhouse, and you do that in a controlled way. And you only have to intake a small portion of the outside air, which is often then drier. If we look for the same solution in the Middle East region, it's a different story. Then we need to have very large capacities of ventilation, especially for the cooling, and it depends on the outside condition. If humidity is between 30 and 40%, then it already becomes challenging to actually manage that and to keep the greenhouse with that air volume in balance. So with the systems, it doesn't matter if it's indoor farm or semi-closed greenhouse, you can make all the configurations you need. So heating and humidification, dehumidification, a balanced situation where you only recirculate some of the air, or a cooling where you extract the air by either a mechanical machine with condensation, or you use outside air for removing the humidity. Depends a bit on the cost of electricity, the outside conditions, and so yeah, for every project that's different. So this is the example of the humidity control. Yeah, I won't go over every step, but it's all the same principle, that it recirculates. If we take outside air from inside, it's heated up to the inside conditions, so you don't have condensation problems along the way, and you don't blow in too cold air, especially in wintertime, because otherwise you get too cold air around the roots. This is a screenshot of the PRIVA control. Every step of the process is controlled. The systems are focused on controlling the whole greenhouse as a climate zone, and not yet on the plant type. I think in the future, well, what Peter also mentioned, that we will be focused more and more on accurate control on plant level. So these systems have to be connected to that. This is a heating example. This is more interesting. Once you use artificial heating, you can recirculate the heat of the lamps better in the greenhouse, so you have a better mixing of the air conditions. This is the technology that it looks like. These are the heaters with a fan that overpressures the heat in the flow. And these are the fans that are below. Yeah, some more screenshots. Yeah, and what you also do is with ventilating and the recirculation of the air, you introduce also the CO2 in the same system. So with the ventilating of the air, you introduce the CO2, so it's also well mixed into the greenhouse. So, and always when I look at this picture, this is a semi-closed greenhouse, but when at night or in the winter time, the screen is closed, and I think we have already a greenhouse of the future, which we will be dependent only from LED lights if the outside conditions are suitable for that, and energy solutions also support that. For indoor farming in multi-layer, yeah, actually same scenario. What's the difference? You stack it in multiple layers, and it depends on the purpose. This is for research, or if it's for different crops that are suitable to do on multi-layer, then you can go to this kind of solutions. But there's not one solution. You have to look for it in every way. So this is a very short nutshell of an eye on the future to give some overview of what happens, and yeah, I hope it brings you on some ideas. Thank you.